Again, we're creating this because based on your do now today, you had to identify which variables work for what equation. And some of us were struggling last time with identifying variables, but it's important to know that each variable has a specific equation tied to it. Some variables are repeated and some are not. So what variables did all three equations? So what I'm going to do for you guys right now is, based on what you see, what do all three variables have in common? Or well, not all variables, all three equations have in common?
Acceleration.
Okay, all three equations have acceleration. So where it says all three, put the letter A to indicate acceleration. So all three of these equations, no matter which one you dive into, have acceleration. What else do all three of them have?
Initial velocity.
Okay, are we agreeing, disagreeing? How are we feeling? All right, good. I see initial velocity here, here, and also here, which means all three have it. Therefore, all three have initial velocities. Go ahead and put that down somewhere. Is there any other variable that all three have in common? What do only two of these equations have? So two of these equations have the same variable, where one of them do not. What variable is repeated in only two of these equations?
Final velocity.
Okay, final velocity is only in two. The first one, which is here, and the last one, which is here. There is no final velocity in the second kinematic equation. That means where it says only two, I'm going to put final velocity there because it's showing me only two equations have it. What others do only two have? What other variable? Time is also in only two of them. It's in the first equation and the second, but not in the last one. So I'm going to put time where it says only two. Any other that you see in only the two?
XF.
Okay, final position, right? Final position is only in two equations. That means it's only in the second equation where it's here, and the last equation when it's here. That's final position, here and here. Is there any other equations? And now we're saying it's starting position. It's not in the first equation, but starting position is in the second one and the third one. So I'm going to go ahead and put starting position here. This is going to help you organize what variables you have, because remember, your next step is you're working with mixed kinematic problems. What this means is you're going to get a problem, but you're not going to know exactly what equation to use. And based on the facts and the variables given to you in the problem, you can identify which one of these equations work to solve that problem. That's why this is important to take notes on. Is there any variable that we have never seen before that's only in one, or never has seen before at all? Is there any variable that you see that we have never seen?
The one in the second problem, that 1/2 OTQ.
Okay, so this is actually half of acceleration times time squared. This is part of the second kinematic equation that we've worked with that looks exactly like this. Does that make sense? This is the second equation. That's that. Do you remember that one? Given fact is, we've seen all these variables before. Given fact is, all three variables have all three equations have two variables in common: acceleration and starting velocity. Only two of them out of the three have four in common: final velocity, time, starting position, and final position. That means, based on my question, if time is given to me, which equation will not work if time is given to me in the problem? The last one will not work for me because time is not part of the last equation. Does that make sense?
Yes.
Okay. If final position is given to me, what equation will definitely not be needed? If final position, which is XF or XO, was given to me, what equation does not include final position? The first one. The first one does not have final position or starting position. Therefore, the first one would not work for the problem if I'm looking for XF or if I have XO. So, I'm going to work through this with you guys. Because I do not know what equations to use, I must try to identify as many what? As many, thank you, variables. Now you're thinking ahead. Variables as I can to see what I need and what I don't. Or just to see what I need, period. So I want you guys to write this down because this is going to be your little cheat sheets for when you do go into the problems. It's important that you do identify as many variables, which means if you're identifying as many variables as you can, how many variables did we just write down that we actually identified?
Bless you.
Thank you. We identified 6 variables total that were in all 3. So what am I going to ask you to do with the all 6 variables when it comes down to the detail? Variables are VO, VF, A, T, XF, XO. And there are 6 of them. Do I need to find all 6 every single time I do a word problem?
No.
No, I don't need to find all 6 every time I do a word problem. Why not? Why? An arrow is projected by a bow vertically up with a velocity of 40 miles per second and reaches a target in 3 seconds. How high is the target located? So first, what variables can you pull out from this?
Time was 3.
Okay, time is 3 seconds. What?
Velocity.
Hold on 1 second. If time is 3 seconds, what equation can we already cancel that we don't need?
The last one.
So right then and there, because time was already given to you, you've already made it easier for yourself by getting rid of what? Okay, because time is already given. But because time is already given to you, you are able to already say the last equation can go. Right then and there in that first moment. Time is given to you, that equation can go. Okay, what else do you have? What variables can you utilize in this problem?
Velocity.
Okay, is it starting or ending velocity? Because that matters. Starting velocity or ending velocity? Okay, why do you think? Because that sounds like you were gonna. Why do you think it's starting?
I think it's starting. Because it's going up. It never said it stopped.
It never said it stopped. It's going up. Okay, I agree with that. Anyone else want to add to why it is or not starting velocity? Based on your opinion. I mean, we could be here forever doing. So.
Can I say what a variable is?
That's fine. We can skip this one and go to a different variable.
I think that A is negative 9.8 because it said it was shot up, but it's going to come down eventually.
So what's acting with it? It starts with a G that we know.
Gravity.
Gravity. Thank you. So we're going to say acceleration is negative 9.8 simply because it's being shot. upwards, vertically. We say that time is 3 seconds because that's when it reached its target. Target reached. Okay, so we have two variables that we're definite about. What else? Agreeing or disagreeing that we're solving for XF?
Can you repeat that?
So know that how high has to do with the target. But I'm looking for that 40 velocity. Everyone is ignoring that 40. But is the 40 a starting or ending velocity? I need to know so I can plug it.
I think it's a starting velocity.
Okay, why do you think it's a starting velocity? What's the hint? What's the hint? Because you are right, but what's the hint?
Because it said it's like projected vertically up with the velocity. Like it clearly states it's going up with the velocity of 40, which means like it's like saying that that's like the beginning.
Yes,
That's
the
how
key word that you literally are all looking at is the word with. If you're working with somebody, are you going ahead of them or behind them?
You're like with them, so you're like together.
You're doing it at the same time, which means as it's shooting up, that is its starting velocity. The moment that bow and arrow leaves me, boom, it's going at 40. It's not slowing down yet. That's its starting velocity. Its ending velocity is whenever it hits that target. It hasn't gone to that target yet. Okay, so my starting is going to be 40 because it never hit the target. The key word is with. I'm working with you, not before you. If it was the final, it would have said after, but it said with. Okay. Do I know my starting position? Why are we saying our starting position is 0?
Because I think that it came from the ground.
Yes. Well, it came from a bow. It's projected by a bow. So that bow is the starting position. The ending position is going to have to be that target. Right? Right?
Yeah.
Did it hit the target?
Yeah.
Did it hit the target yet?
Not yet.
Not yet.
No.
Did it come to a rest yet? We don't know what the final velocity is done because it never hit the target, nor did it come to a rest. So I can get rid of that. First thing first, we did a lot of work. Realistically, we didn't have to go that far, but we did for a reason. Second thing second, which variable did we get rid of that we say we don't really need?
T.
Yeah.
Wait, what? I mean, not variable. Which equation did we not need? Because we were like, done work with because we had T. What equation did we? We got rid of the last one. That means we only have the first and second one to work with. What does the first one have that the second one does not?
Final velocity.
No, it does. It's right here.
The final position.
Position. And what is our question asking us to find?
Final position.
So which equation works best for what I'm looking for?
Last one.
The last one?
The second one.
The second one.
Oh my God, I meant second one.
I know what you mean though. But first of all, we started this equation saying, hey, Miss E, time is given to me, last equation can go. Oh, I'm looking for how high, first equation can go. Took me 3 seconds to figure out using those two hints. Hint number 1, time is given to me. That last equation don't got no time, bye. Hint number 2, oh, I'm looking for how high. Oh, well, this one doesn't tell me, the first equation doesn't tell me how high. The second one does. Thanks. Done. Does that help a little bit? What's given to me? Look, first of all, based on that question, what am I solving for?
VO is 0.
Wait, what am I solving for? Based on this
Final
last.
velocity.
I'm solving for final velocity. Okay, we know we're solving for final velocity. What's given to me in this problem that I can't even use in all of them?
Acceleration.
I can use acceleration. All of them have acceleration. We've proven that. What's given to me in this problem? Time is given to me, and which one doesn't have time?
The last one.
The last one, so the last one can go, and I'm looking for its velocity after. What am I finding? Is it the final velocity or the starting velocity? Based on the question.
Final velocity.
So, which one makes more sense then?
The second
one.
The second one has final velocity? I didn't know that.
No,
The first one.
The first one, because y'all told me time is given to you, Miss E. Get rid of the last one, and it's asking me the final velocity after. Get rid of the second one, there's no final velocity. Does that make sense a little bit? I know I'm moving it fast, but I'm recording this for a reason. But we're looking for, that's how you know what kinematic equation to use. Look at this one. What's the question asking you to find?
Acceleration.
Does all the equations have acceleration?
Yeah.
Okay, so they all have acceleration, so I can't cross anything out yet. Is time given to me in this equation?
No.
Am I looking for time?
No.
So which ones can go? Time isn't given to me, nor am I looking for it. So which one do? The first two can go. Time isn't given to me, nor am I looking for it. Bye, because you both have time. So that means what equation can I use for the last one then? For this one? Huh?
The last equation.
The last equation. All this entire thing is being able to find out which equation to use based on facts given to you in the problem. If you know what's given to you in the problem, you know that, okay, well, this equation got time here, but not there and there. Well, I'm not using the second equation because it doesn't make no sense. If I'm looking for final velocity, but the second equation don't have any final velocity. Or if I'm looking for position, but the first equation doesn't have position. So why would I use it?